Okay, so today we are going to work on solving absolute value equations. But before we do that, we're going to do a quick warm-up, and we're going to review simplifying absolute value expressions. So, quick review, the definition of absolute value is a number's distance from 0 on a number line. And so if I think about a number line, I'll draw a number line here. I put 0 in the middle, so here's like 1, 2, 3, 4, 5, 6, 7, 8, right? And then my negatives, -2, -4, -5, -6. I'm just numbering every other one. And I'll go a little bit further. -9, -10, right? So, number one, the absolute value of 6. If I find the number 6 right here, how many spaces is it from 0? I start at 0 and I count 1, 2, 3, 4, 5, 6. So the distance from 0 is 6. Over here, absolute value of -10 is right here. Its distance from 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted 10 spaces. Although the number is -10, I want to know its distance, and distance can't ever be negative. So that answer is just +10. Now, absolute value, when we simplify, acts like a parentheses. So think like PEMDAS. You would simplify the absolute value at the P, for parentheses. So I have to simplify in the absolute value first. 7 minus 9 is -2. And then I simplify the absolute value of -2 is just +2. And then in number 4, notice I basically have like two absolute values and then a plus sign in the middle. So it's like parentheses, parentheses, add. Well, PEMDAS, I would do the parentheses first and then I would add last. So I have to simplify. The absolute value of -5 is 5, because the distance from -5 to 0 is +5. Absolute value of -3 is 3. And then I add, so that answer is 8. Okay, now that we did a little review on simplifying absolute value, let's solve an absolute value equation. So number 5, I have absolute value of x equals 4. In other words, find me a number whose distance from 0 is 4. So if I think about my number line, here's 0. I can go out 4. I want like a distance of 4 from 0 in either direction. So I can go 1, 2, 3, 4. And I would get to 4, right? Or I can go 4 spaces to the left and get to -4. So there's actually two numbers whose distance from 0 is 4. So it would be -4 and +4. So I'm going to actually have two answers. X equals -4 and x equals +4. And you're going to see today, when we talk about absolute value equations, that's our goal for today. When we talk about absolute value equations, a lot of times you are going to have two solutions to the equation, because when we talk about distance, we could go in the negative direction or we could go in the positive direction. So we're going to talk about what it means to isolate, and then we're going to solve some absolute value equations. Okay, so what does it mean to isolate? Well, to isolate a variable, it means to get the variable by itself. Okay, So we want to isolate, in this case, not the variable, but we want to isolate the rectangle in each equation. Just pretend it's an x. So if this were like x minus 4, instead of a rectangle, we would do the opposite operation, and we would add 4 to both sides, because negative 4 plus 4 cancel. And then remember, now I have a rectangle instead of an x, but 4 plus 9 is 13. So I've just isolated the rectangle. In number 2, this means 2 times rectangle equals negative 10. So how do I undo multiplication? I divide. So rectangle equals negative 10 divided by 2, negative 5. Number 3, here's my rectangle here, right? So it's separated by a plus, and now I have this 6. So what's the opposite of adding 6? Subtracting 6. So 6 minus 6 cancels, right? And now I have to subtract 6 from the other side of the equal sign. And rectangle equals 9. 15 minus 6 is 9. Okay. Couple more. So number 4, my rectangle's here. When I have this fraction, this is a fancy way of saying division, right? The opposite of dividing by 5 is multiplying by 5. So I can multiply both sides by 5, and I get rectangle equals negative 10. 5 and 6 are a little trickier. These are two-step equations, but this means negative 4 times rectangle plus 1. So remember, I'm going to get rid of my addition or subtraction first. So I'm going to subtract 1 from both sides. I have negative 4 rectangle equals 6. And then this means negative 4 times rectangle. So to get rid of the negative 4, multiplying by negative 4, I'm going to divide by negative 4. So those negative 4's cancel, and I have rectangle equals negative 6 over 4. Now I can reduce that fraction, negative 3 over 2. Or if I wanted to, I can convert that to a decimal too. So either one of these answers is acceptable. And then finally, number 6. This means 6 minus 3 times rectangle. So I have to get rid of this 6 first, this one right here. So I'm going to subtract 6 from both sides. I have negative 3 rectangle equals 9 minus 6 is 3. I'm going to divide both sides by negative 3. And I have rectangle equals negative 1. Okay. Now, we know how to isolate, in this case, rectangles, but remember, it works the same way if they were like variables. Now, these rectangles in a few minutes are going to turn into absolute value symbols, and hopefully these rectangles kind of should look like almost like an absolute value. You'll see what I mean in just a second. But here's your steps for solving absolute value equations. We're going to isolate the absolute value quantity, meaning it's kind of like that's the rectangle. We're going to isolate the rectangle. Then we're going to remove the absolute value bars and split into 2 separate equations. The first equation is exactly what you see without the bars, and the second equation is almost the same, but you make the right side negative. Again, you'll see what I mean in just a second, and then you solve both equations. Let's go through some examples. So number 1, absolute value of x equals 12. So remember, think of this absolute value as like the rectangle we were just isolating. So is that absolute value isolated? In this case, it already is. So step 2, I'm just going to split, and I'm going to drop the absolute value bars. So x equals 12. And then I'm going to write another equation with the absolute value bars dropped as well. And I'm going to make the 12 negative. And then I would look at these equations and I would solve it if I could. In this case, I can't solve for x anymore. So I'm just leaving it. Okay, number 2. Again, the absolute value is by itself, meaning here's my equal sign. The only thing on that left side is the absolute value. So I'm step 1, isolate. I don't have to do that. Step 2, split into 2 equations. So drop the absolute value, x equals positive 9, and then drop the absolute value, make the 9 negative. That's step 2. Step 3 is to solve for x if you could. In this case, I can't. It's already, or I should say it's already solved for x, so I'm done. Okay, number 3. If I look at number 3, here's my equal sign. Step 1, isolate the absolute value. The absolute value is not by itself. Again, think of the absolute value as like a rectangle, kind of like what we were working on before, right? How do I get the rectangle or the absolute value by itself? Now I have to get rid of that plus 3. The opposite of plus 3 is minus 3 from both sides of the equation. So plus 3 minus 3 cancels. I just have absolute value of x equals 7 minus 3 is 4. Now that absolute value is by itself on the left side. So step 1 is done. Isolate the absolute value. Step 2, split into 2 equations. So x equals positive 4 and x equals negative 4. Remember, when I split into 2 equations, I have like just drop the absolute value, make the number positive, and make the number negative. So number 4, here's my equal sign. Again, that absolute value is not by itself. I have this minus 4 here. What's the opposite of minus 4? Plus 4. So I'm going to add 4 to both sides. I have absolute value of x equals 11 plus 4, which is 15. So now my absolute value is by itself. So step 1, isolate the absolute value is done. Step 2, I can now split this into the positive case and the negative case. So remember, I'm dropping the absolute value and keeping everything the same. And now I'm dropping the absolute value and making the number on the right-hand side negative. So kind of like what we've been saying, I have 2 solutions, right? Positive 15 and negative 15. Okay, number 5. Now, number 5 looks a little different than the ones that we just did, but the absolute value is still not by itself. It has that 2 out in front. This means 2 times absolute value of x. So to undo multiplication, I'm going to divide both sides by 2. That cancels. Now I have absolute value of x equals 12 divided by 2 is 6. So step 1, isolate the absolute value. The absolute value is now isolated. It's by itself. Step 2, split into the positive case and the negative case. Hopefully this is starting to make sense. Let's try number 6. So this is negative 5 times absolute value of x. We need to get rid of that multiplying by negative 5. We're going to divide both sides by negative 5. So absolute value of x equals negative divided by negative is a positive, and 100 divided by 5 is 20. Now I have the absolute value by itself, so I split into the positive case and negative case. Okay. Let's try some more. Now we're going to get a little bit more complicated. So number 7, here's my absolute value on the left-hand side. And I drew a little line where my equal sign is. So to isolate that absolute value, this means 3 times, and then I have the minus 5. I have to get rid of that minus 5 first. I'm going to add 5 to both sides. I have 3 absolute value of x equals, and then 16 plus 5 is 21. So how do I get rid of that 3 times absolute value of x? The opposite of multiplication is division. So I'm going to divide both sides by 3. So 21 divided by 3 is 7. Now that absolute value is isolated, I'm going to split into x equals 7 and x equals negative 7. All right, number 8 is really similar to number 7. So to get the absolute value by itself, I'm going to start by subtracting 32. 32 minus 32 cancel. So negative 8 minus 32, use your calculator, but that's negative 40. I have negative 4, absolute value of x equals negative 40. Now, this means negative 4 times. The opposite of multiplying by negative 4 is dividing by negative 4. So I have absolute value of x equals, negative over negative is a positive 10. So now, like we've been saying, my absolute value of x is by itself. So I split into x equals 10, x equals negative 10. Okay, so in all of the equations that we've done so far, in the absolute value, it was just an x. You're going to notice now in like number 9 and in the future problems that we do here, there's more than just an x in the absolute value. But the steps are the same. So step 1, isolate the absolute value. So think of it as a rectangle. Look at the equal sign. The only thing on the left-hand side is the rectangle, right? So step 1 is done. The absolute value is isolated. So now we're going to go to step 2, split. So we drop the absolute value. So it's x plus 3 equals 19. And then I write a second equation and I drop the absolute value, but I make the 19 negative. So now my 2 equations, I have to now solve these. So I have x plus 3 equals 19 and x plus 3 equals negative 19. And now to solve the one on the left, I'm going to subtract 3 from both sides. And 19 minus 3 is 16. And now on my equation on the right, I also have to subtract 3 from both sides. But I have negative 19 minus 3, which is negative 22. And so, again, all my other answers were like x equals 10 and negative 10, 7 and negative 7. Now I have 2 totally different numbers, 16 and negative 22. It's not like a positive and a negative value, right? Okay, so 10, isolate the absolute value. Here's the equal sign. The only thing on that left-hand side is that absolute value, or like the rectangle. Make it a rectangle if that helps. So step 1, I don't have to do. I don't have to isolate anything. It's already done for me. Step 2 is to split. X minus 14 equals 2. X minus 14 equals negative 2. Because I drop the absolute value and set it equal to positive 2. And then I make the 2 negative. So those are my 2 equations. And now I just solve. So to solve, I'm going to add 14 to both sides. Negative 14 and plus 14 cancel. So I just have x equals 16. And then over here, when I add 14 to both sides, I get x equals 12, because negative 2 plus 14 is 12. So those are my 2 answers there. All right, number 11. The absolute value is by itself. So here's my equal sign. The only thing on the left is the absolute value. So step 1, isolate. It's already isolated for me. Step 2, split. So I just drop the absolute value. So I keep the 2x equals 30. And then I drop the absolute value, but I make that 30 negative. Notice I'm always making the part negative that's out of the absolute value, right, to begin with, like the right-hand side. Now I'm solving. So I have to divide by 2. X equals 15. Divide by 2. X equals negative 15. Okay? Number 12 is really similar to 11. The absolute values by itself on that left-hand side. So step 1, isolate. It's already done for me. Step 2, split. Negative 7x equals 35. Negative 7x equals negative 35. So I have my 2 equations. Now I'm going to solve each of them. Divide by negative 7. X equals negative 5. Divide by negative 7. X equals 5. So there's my 2 my 2 solutions. All right, we have a couple more. So number 13. The absolute value is by itself. So step 1, isolate, I don't have to do. Step 2, split. I'm going to drop the absolute value and just make this 4x minus 5 equals 3. And then I'm making the 3 negatives. So 4x minus 5 equals negative 3. Notice I don't change the 4x minus 5 ever. But now this is going to be a little more complex to solve for x. So when I solve for x, first thing I do here, I'm going to add 5 to both sides. So I have 4x equals 8. And then I'm going to divide by 4. So x equals 2. And then over here on the right, I'm going to add 5. But negative 3 plus 5 is actually 2. And then when I divide by 4, I get x is equal to 2 over 4, which can be reduced to 1/2. So I have x equals 2 and x equals 1/2. All right, number 14. To isolate the absolute value, because look, if I draw my line, now I have this 3 and I have this negative 1. Here's my absolute value, or think of it as the rectangle. So I need to get rid of those. Remember, I need to get rid of the plus 1, or I need to get rid of the negative 1 by adding 1 to both sides. So I have 3, absolute value of x plus 2 equals 8 plus 1 is 9. And then this means 3 times absolute value, so I'm going to divide both sides by 3. I have absolute value of x plus 2 equals 9 over 3 is 3. Now step 1 is done for me. Or not for me. I just finished step 1, I should say. I isolated the absolute value. And now step 2 is when I can split the absolute value into 2 equations. So I'm splitting into the positive case and the negative case. So x plus 2 equals 3. And then x plus 2 equals negative 3. And now to solve, I'm going to subtract 2, and I get x equals 1. And then I'm going to subtract 2 and get x equals negative 5. So there's my 2 solutions. Number 14 was definitely the trickiest one we've done so far. And number 15 is going to be really similar. So here's my equal sign. I need to get the absolute value by itself, or think of it as, again, the rectangle. So I need to get rid of the 2 and the negative 3. So I get rid of that minus 3 first by adding 3 to both sides. And then I have 2 absolute value of x plus 5 equals 10. And now I have this 2 times the absolute value. So we got to get rid of that. We're going to divide both sides by 2. And we have absolute value of x plus 5 equals 10 divided by 2 is 5. So step 1 is done. We've isolated the absolute value. Now we split. x plus 5 equals 5. X plus 5 equals negative 5. Now we solve. We're going to subtract 5 from both sides. X equals 5 minus 5 is 0. And then when we subtract 5 over here from both sides, we have negative 5 minus 5, which is negative 10. So there's my two solutions. All right. Thank you guys so much for watching. Hopefully this was helpful in learning how to solve absolute value equations.